Hi, here's a demo of a little tool which I've put together today to show the effects of flicker. Flicker is an unfortunate consequence of the way that I've arranged for the Mark II PV power router to divert power, which it does by putting a 3 kilowatt load on and off to match the amount of surplus power that we have. The problem with that is that a relatively high power load coming on and off does cause the local mains voltage to go up and down a little bit, and that makes any nearby lights flicker. So what I've got here is a little rig. It's off the picture. It's a standard circuit board set up for a PV Mark II PV power router. So it has the triac on there by which the load is put on. I have a voltage sensor which is connected to the local mains via a transformer. The only reason that the voltage sensor is needed for this is to align with the mains cycle, so the triac knows when to be, I know when to switch it on and off. The current sensor isn't used because all the currents are simulated both for what we're generating from our PV and what we're sending out to the dump load. So the system's sitting here as of startup. This is the serial window, and it's really the line at the top where the cursor is flashing, which is the important thing. Immediately underneath it there's a little user menu. You can put in N for normal mode, A for an anti-flicker mode, and put in some digits, and that's the amount of power you're choosing to generate. So at the moment we're not generating any surplus power, so there's nothing much going on. So if I put in 500, hopefully something will start to happen. 500 goes into the little box on the top, followed by carriage return, and I don't know how well it's going to pick up on the screen, but we have got some quite unpleasant flicking going on. So the flicking that I hope will appear on the screen is actually a light bulb. It's a 60 watt light bulb, just catching a piece of paper there. So this is more than this is serious flicker. This is 100% flicker. This is the light going fully on and off, whereas the flicker that we're trying to avoid with Mark II as a concept is very much of a secondary nature when the voltage goes up and down a little bit, a couple of volts, as a result of putting on a 3 kilowatt load. This is 100% depth, so I just want to make it clear that this isn't the sort of flicker that Mark II generates on nearby lights. This is just a demonstration of the rates of it, so we can see what's happening. So that's with 500 watts of surplus power. If I increase that to say 1000 watts, 1000 up in the top. Now again, I don't know how well the camera will pick it up, but the flashing is faster because we've got more surplus power. If I go to 1500, now this, I think 1500, that's the fastest flicker we're going to get, and essentially the triac is on for one cycle and then off for one cycle, so we're going to be seeing 25 Hertz flicker there. So this is a good point to invoke the anti-flicker mode. Hopefully you can see this on here. We're in the normal mode now with 1500 watts. If I go A, it's little a, it's case specific, I think. So if I go to little a, carriage return, we're now in anti-flicker mode. And what anti-flicker mode does in this implementation, as we've talked about on the forum, this actually has two thresholds, one of which is at 80% of the way up the energy bucket, and one of which is at 20% of the way up the energy bucket. So the triac works on the basis of a hysteresis operation. So when the bucket level gets to 80%, the triac goes fully on and stays on until the level gets to 20%, and then it turns off until the level gets back to 80% again. So because I've got 1500 watts of simulated power and 3000 watts of simulated dump load, the charge up rate and the charge down rate are exactly the same. If I went to a higher rate of surplus PV generation, like 2700, so that's 90% of the dump loads rate, So we've got 2700 here. We'd expect the system to be dumping power for 90% of the time, and it now takes quite a long time to get from the lower threshold to the upper threshold, so the off stage will be quite short but the on stage will be quite high. So we've now got a flicker rate of only one flicker cycle every few seconds, and I think this rate with 90% surplus power will actually be the same rate as if I went to 10% power, which is 300. So now we'll have the inverse, where it'll be on for a short time and off for a long time. I think there's a symmetry about when we have 50% power, because then the rate at which the bucket climbs is exactly the same as what it falls. So this to me doesn't look unpleasant flicker. Yes, you would be able to see the lights come on and off a little bit, but that's no different to when somebody puts on a kettle or jumps in an electric shower or whatever. So I'm pretty convinced that the most significant frequency or situation we're going to have to deal with is the half power rate. So putting that in again, 1500. So I think this is 1.4 seconds. It's 1.2 seconds if you use 50% of the energy buckets window. I think it's gone up to about 1.4 seconds by setting the limits a little bit wider at 20% and 80%. You could make them wider still, but if the calibration were to be a little bit out and you exceeded the buckets window, then you would start losing power or paying for power that you're consuming, and that's clearly not a good idea. So with this simple two threshold operation and a 3 kilowatt load, I think this is about the slowest we can get the flicker to get. So it's just over 2 seconds rate, and if we went back to the normal mode, which is N, carriage return, I'm not convinced this is going to show up very well on the camera, but it is flashing at 25 Hertz and it's quite unpleasant on the eyes. So if I go down to say 100, so this is 1/30th, we're getting one flick every 30 cycles, which I don't know if the camera's picking that up. It should do. And if we put that onto the anti-flicker mode, then we would obviously slow it down an awful lot. It would take an awfully long time to climb up to the top. Whether it will do so before I run out of patience, I don't know. But once it does get to the top, it drops back down to the bottom very quickly, and it'll take another lengthy time to climb back up again. With only 100 watts, and you're aiming for 2700, it's going to take 27 seconds or so. So this is hardly a flicker rate, this is just an occasional on and off. So by putting in this simple second threshold and moving between the two on a hysteresis basis, we've slowed down the flicker from 20 Hertz downwards up to, we've slowed it down to about 2 Hertz, or I think it might be 2.3, 2.4. Sorry, one cycle every 2.3 or 4 seconds, so that's only 0.4 of a hertz or something like that. So the flicker is never greater than about 0.4 of a hertz if you're using this new mode. And from what I can see, the only downside of using this new mode is that you have to have a calibrated system, whereas previously for all of the Mark II designs that I've put out, calibration essentially hasn't been important, because you just have one threshold and the system rattles around that threshold within a very tightly controlled band of just a couple of cycles worth at 60 joules per cycle. So that's a couple of 100 watts it floats up and down in, and whatever the calibration is, it doesn't matter. But with this anti-flicker mode option in there, you are going to have a properly calibrated system, which, if combating the flicker is important, I think is a very small penalty to have to pay. Just thinking about how you would calibrate the system, it's pretty straightforward, because, for example, if I go to 1500 here, so we're simulating 1500, we're losing 3000 whenever the trike is on. There is a known frequency at which this system should be toggling, and if this was a real system rather than a simulated one, and it's not toggling at that rate, well, you would need to alter the power cal factor until it does. So once you've got the system toggling on and off at the right rate, then you know calibration is correct. So that will be a very easy way to calibrate a Mark II type system which has this anti-flicker mechanism in there. More details will be on the forum of the Open Energy Monitor, and I look forward to any feedback about this there. Thanks for watching. Cheers for now.